Alright, hi, so we're going to do a video. There's not going to be a file today, okay? Let's get right to it. Greg bought 4 notebooks for $6.40. So we want to find an equation, which the 4 equations will help you find the price of a notebook. So the first one says, price of a notebook divided by 4 equals 640. That makes no sense at all. Price of a notebook divided by $6.40 equals 4. That also makes no sense at all. 4 times the price of the notebook equals 640. So I'm hoping you see that's letter C. Okay, so this is the only equation that makes any sense. 4 times about 4 notebooks, multiply by the price, and that will give you a total of $6.40. Wow. And what is the price in dollars of one notebook? Well, the price in dollars of one notebook, well, remember, let me just write this as 4 times P equals 6.40. Excuse me. So this is an equation. There are other ways of doing it, but if you did it this way, let's just continue doing it this way. This is a multiplication equation. There's a multiplication sign here. So remember, a little line like that. We're going to do the inverse. And the inverse here of multiplication is division, so we're going to divide. Here's my division. I'm going to divide by 4. I'm going to divide this side by 4 as well. That gets cancelled out. And we have left with P, and 6.40 divided by 4 equals 160. Okay. That's the price of our notebook for one notebook. Okay. You could have done it another way. Once you get the equation, if you wanted to do it like this, you have a proportion for 640 equals 4 notebooks. And how much would be 1 notebook? Okay, what's the relationship here? Divide by 4. And also here, divide by 4. You would have gotten the same answer. Okay? Let's move on. So, like yesterday, I'm going to be pressing pause because I have to read the questions. So I don't want to waste time. Let's see, question 2. Chad drove 168 miles in 3 hours. How many miles? Okay, so this one, again, this one we can definitely use what we're used to do. Write this as a fraction, 168 miles in 3 hours. First question, how many miles per hour did he drive? Simple. 1 hour, let's change that to unit rate. Divide by 3. Divide by 3. Okay, and remember, this one you were allowed to use a calculator, only because you get some practice. 168 divided by 3, and so will I. You get 56. 56 miles an hour. Okay. 2. Chad will drive 672 more miles. He continues to drive at the same rate. How many more hours will it take to drive 672 hours? Well, we know what the unit rate. Okay, remember what I used to say? Once you have the unit rate, you can do whatever you want. So 56 miles in 1 hour. We know that. Okay, that's what he always does. So he wants to drive 672 miles. Find a relationship. And I'm hoping there is one. That's nice, actually. And let's see. Yes, there is. Times 12. And it'll be 12 hours. Okay. Part C. Chad stopped at and filled the car with 11 gallons of gas. He had driven 300 miles using the previous 11. He had driven 308 miles using the previous 11 gallons of gas. So he drove 308 miles with 11 gallons of gas. So we want to know how many miles he drove with 1 gallon. So again, set up your proportion here. So there is a relationship. Divide by 11. And let's go on top, divide by 11, and you get 308 dividido por 11 sale 28. Okay? Nice and simple. Ooh, there's a part D. Chad's car continues to get the same, how many more gallons of gas will you use to 672? Alright, so we know, so now we want to know, we know that it's 28 miles takes 1 gallon of gas. How many gallons of gas will it take if he wants to drive 672 miles? Well, again, not a biggie. 672 Let's see. And that is 24 miles because it's times 24. Therefore, times 24 at the bottom, 24 gallons. So if he wants to drive 672 more miles, it's going to take him 24 more gallons. We're moving. Okay, so pause because I got to read this. Pause. Alright, so the question says here that there is a ratio of 2 pine trees for every 3 maple trees. So now we are to look at these 4 graphs and see which one represents a ratio of 2 to 3. Let's look at graph A. In graph A, if you look at that dot, it says that for that one says 100 pines. Okay, and if you go straight up, you get 200 maple. That is not a ratio of 2 to 3. That's a ratio of 1 to 2. So A, choice A, is not what we want. Choice B. Let's go to choice B. Choice B, I see 200 pines. And if you go up, it says 100 maple. That is also not a ratio of 2 to 3. Okay? Even if you simplify, that's a ratio of 2 to 1. So choice B, it's not what we want either. Choice C. Get 120 pines. And if you go straight up, you get 180 maple. Let's see. So we have 120 and 180. I'm going to simplify. Let's divide both sides by, let's say, 60. Okay, so if I divide 120 by 60, I get 2. And if I divide 180 by 60, I get 3. Oh, look at that. A 2 to 3 ratio. So choice C is the correct one. I'm not even doing choice D. Okay. Next question. Number of blueberry muffins that a baker makes is 40% of the total muffin. Ooh, that makes it is 40% of the total number of muffins she makes. What? Oh, so there's a okay. Blah. Blueberry total. Okay, so I'm going to set it up like this because it looks like it's going to be one of these. I'm not sure yet. So I know that they make a certain quantity, 100% of blueberry muffins every day, and I know that out of the 100%, 40% are blueberry. That much I know. Okay, so on Monday, the baker makes 36 blueberry muffins. Okay, what's the total number of muffins the baker made on Monday? So on Monday, out of the 100%, 40% were blueberry, and that 40% meant 36 actual muffins. What was the total? Well, is there a relationship from 40 to 36? No, but we can make one. Let's divide top and bottom by 10. Divide top and bottom by 10. I'm going to get 4, and I'm going to get 10 divided by 10 here. Okay, no longer going to use this. Now there's a relationship between 4 and 36, which times 9, and the bottom is going to be times 9, and that gives me 90. So how many muffins did they make on Monday? 90, and 40% of that was 36, which were blueberry. On Tuesday, the baker makes 60 muffins. Okay, so again, 100%, and out of the 100%, 40% are blueberry. And in this case, we know that on Tuesday it's different. She makes 60 muffins. So if she made 60 muffins, how many were blueberry? I know 40% of them were blueberry, but we got to find 40% of 60. All right, so that's my that's total. It's my part, so that's my proportion. Is there a relationship? No, I don't. Let's just simplify this to 4 over 10 because that works nicely. Okay, divide top and bottom by 10 times 6, and obviously times 6 on the top. And 4 times 6 is 24. So on Tuesday, out of the 60 muffins that were made, 24 were blueberry. A lot of calorie on those. Shelby biked 21 miles in 4 hours. Okay, anytime I see a ratio, okay, anything that's being compared, I like to write it as a fraction. So 21 miles in 4 hours. And look at that. Part A says what's the average mile per hour? So 1 hour. Set it up. Divide by 4. And divide by 4. That's going to get us 5.25 miles in an hour. At that same rate, how many hours will it take Shelby to bike 42 miles? Now, you can take either this one or this one to set up your next question. So again, I'm not going to use this. You know what? We can use either one. Okay, I'm going to use the original one, 21 miles in 4 hours, and I'll tell you why in a second. If you can do 21 miles in 4 hours, how long will it take you to do 42 miles? Well, the only reason I use the first one is because, look, nice relationship. We're trying to find number of hours. This is simply times 2. Wow. And this one times 2, so it gives you a total of 8 hours. You could have used the top one, it could have given you the same answer. You could have used this ratio right here and given you the same exact answer. Okay. Which of these expressions represent the sum of 3 and number? The sum implies addition. What are we adding? 3 and n. Is there anything that looks like that? Yes, there is, and it looks like, oh, select all that apply. So you got B. B is n plus 3, but in addition, remember, n plus 3 and 3 plus n, same thing, so that checks. And C says 3 plus n. That's also check. And D, no, and E, no. So, correct answers, B and C. An advertising company is designing a new logo that consists of a shaded triangle. Oops. A shaded triangle inside a parallelogram. What is the area in square units of the parallelogram? Ooh. Okay, so now this one, you had, remember, parallelogram. Remember what we did in class? You can cut that out. So here you have your parallelogram. Okay. Area of a parallelogram. Hopefully everybody remembers. Base times height. Okay. I could have, if you want to cut this part and moved it here and create a rectangle, but I'm not going to do that. Okay, I'm just refresh your memory. So here you have your parallelogram, sort of. And all you have to do is count the units. So if you, this is D, this is C, A and B. So we need to find the base. Here's our base. Count that, and it looks to me like 1, 2, 3, 4. So our base is 4. Our height. Remember, your slant here is not the height, and this slant here is not your height. Your height is this one. So go to point C. Go to count straight up to point A, and you're gonna get 1, 2, 3, 4, 5, 6. And you're gonna get a height of 6, giving you a total area of 24 units squared. That's part A. In the new logo, what fraction of parallelogram is shaded? Well, let me erase this part right here. What fraction of the parallelogram? So this, your parallelogram, I'm sorry, what your triangle, change colors, your triangle is this right here. This guy's your triangle. Okay, so this triangle right here is half of this. Okay, and you can also divide the bottom one into fourths. So that particular triangle occupies, out of the 4 available spaces, one of them. So the triangle is 1/4 of the parallelogram. Is there 1/4? Yes, there is. Letter C. Okay. Alright. Okay. Next one. There are 5,280. Okay, here we go. Nope, 5,280 feet in 1 mile. And how many inches are in 2 miles? Jeez, really? Okay, so I do know that how many, 1 foot, write that down, equals 12 inches. Okay, hang on a second. Computer's heating up. Let me just stop.